So if none, let's continue driving to acceleration. Okay. By definition, acceleration is the time derivative of velocity. So, mm, acceleration pa, no, is equals to time derivative of velocity. We have velocity, which is as above, around r. So if we're going to derive this one and simplify the terms, nakuha ta ang equation for acceleration. So this is r, e r o, r dot e r plus r theta dot e theta. Okay. So the derivation of that is the same Japan product, mali Japan product rule. R dot, R double dot, I mean, times ER plus ER dot times that, which is R dot plus R dot times sa too, which is theta dot into theta, plus sa too naman, theta double dot times ang remaining, and lastly, A theta dot times the remaining R theta dot. Okay, let's simplify by substituting equations, this equation to ER and E theta. Whenever we see ER dot and E theta dot, let's substitute. Okay, so wala din R dot, ER, nothing. This one, ER. You know that ER is theta dot E theta. Theta dot E theta. Theta dot E theta. So, R dot theta dot E theta na lang. Pagpatuo ko na lang ang aton na unit vector. Okay, E theta. We have E theta. Yes, we have E theta, which is equivalent is negative E theta ER. Negative theta dot ER. Correct? Yeah, negative. Ay, hindi na siya gilit dot. So, as is na siya, as is. This is, again, R dot theta dot E theta. Next. Wala man. The same dyan po, wala sa dot. Isla ko lang, mo ko lang, rearrange ko lang. And the last one is may isang E theta dot. Kamalisan. E theta dot is negative theta dot ER. We have 10 minutes left. Time magiging siya for next discussion. What? Negative theta dot ER. Theta dot ER. Negative theta dot ER. Negative theta dot ER. Or theta dot. Correct. So, isla ko lang siya. May muna siya negative R theta dot squared ER. Okay? So let's collect similar terms. This would be A, ER, and ER and R. That would be R double dot minus R theta squared ER plus E theta. This is a double, eh? And this one. That would be R double dot plus 2 R dot theta dot E theta. So this is the vector notation of the acceleration. Let's separate them for the components. This is ER. So the acceleration component along with the axis is ER is, we need to be consistent. And that would be R dot minus R to the squared ER and our radial transverse R double dot plus 2 R dot theta dot. These are vector rotation, and for the scalar rotation is just ER R double dot minus R theta dot squared, and E theta is equals to R double dot plus 2 R dot theta dot. This is scalar notation. And for the magnitude, A is equals to AR squared plus A theta squared. Okay, so these are the derivations for velocity and acceleration using equations from deriving the unit vectors and the position vector. Okay.